So this is A2Pure Maths. We are on chapter 6 and we're looking at the binomial series then now for any rational n. So last year it wouldn't have been C1 and C2, it would have been our AS Maths that we learnt this. But in AS Maths we learnt that it would work then kind of for any whole number, and so we're able to do it for whole numbers. Now we're moving on to where this n now can be a fraction, or this n could be a negative number as well. And we use this expansion which you would have learned last year. With the expansion terminated at the term x to the power of n, where n is a positive integer. So that was last year's stuff. However, if n is not a positive integer, then the expansion does not terminate, so it goes on forever, and is only valid for x between -1 and 1, i.e. the modulus of x, which we've just done, is less than 1. In this case, the expansion gives an approximation to 1 plus x to the power of n. So obtain the first 4 terms in the expansion of 1 over 1 plus x. Obviously we know that over 1 plus x, let me change my pencil here, is the same as 1 plus x to the -1. So we are simply going to substitute in -1 for our n every time here and work out what we have then. So let's go for 1 plus x to the -1 equals 1 plus -1 x plus -1 minus 2. Hope you can see that okay. Over 2 factorial x squared. This pencil's no good either. Plus -1 minus 2 minus 3 over 3 factorial x cubed. Let's tidy that up. That's 1 minus x. -1 times -2 gives me 2. 2 divided by 2 factorial. 2 times 1 is just 2, so that disappears. We end up with a plus x squared. -1 times -2 times -3, of course, gives -6. 3 factorial is 6, so that gives us a minus then, so it's minus x cubed. And I'm sure you can work out how the rest of it would go anyway. Therefore, final wee line here. 1 plus x to the power of -1 equals 1 minus x plus x squared minus x cubed, and that's valid for modulus of x is less than 1. Second example then. Obtain an expansion of the square root of 1 plus x up to the term in x cubed. So we know that the square root of 1 plus x is the same as 1 plus x to the power of a half. So again, if we look at the top of our page, we're going to substitute our n for a half every time here and then work out from there. So 1 plus x to the half is going to be 1 plus a half upon x plus a half upon a half minus 1, so that's going to be minus a half all over 2 factorial x squared plus a half times minus a half. A half take away 2, then it's going to be minus 3 over 2 all over 3 factorial x cubed. Let's tidy this up then. That's 1 plus a half x. It's going to be a negative first of all because a half times a half. Half times a half would give me a quarter. Divide that by 2, then I'm going to get an 8. And remember that it's a minus. So it's an 8th then x squared. This is going to be a plus, can you see that? So minus and a minus, then that cancels out, so it's a plus. And let's see what we have. On the top line, we're going to have 1 times 1 times 3. So we have 3 over 8 divided by 6. So that's actually 3 over 48, which cancels down into 1/16. So that's plus a 16th. Other ways of doing that to tidy it up, and that's okay. Final line then again for this one. Therefore, the square root of 1 plus x, which is what we get asked for, equals 1 plus a half x minus an 8 x squared plus a 16th x cubed, and that then is valid for, again, modulus of x is less than 1.